I'm Sri Mahita and I'll be presenting our 15 puzzle project, a graduate level web application that transforms the classic sliding puzzle into a modern full stack game. We've implemented 9 advanced features, including secure authentication, custom backgrounds, admin management, leaderboards, and sophisticated animations. The project demonstrates my mastery of React, PHP, Postgres, and cloud deployment. Our 15 puzzle features a 4x4 grid with mathematical algorithms ensuring solvable configurations. At the start I've used BFS to solve the puzzle, but later on I've switched to using A-style algorithm for a faster approach. The leaderboard system implements puzzle type filtering, showing only the best time per user per puzzle type, and custom backgrounds allow the users to upload images from their local. They will be stored in Supper-based storage, requiring admin approval before becoming available. And user management includes registration, login, password reset, and persistent sound preferences. For example, if there are any users that don't want to hear the sound of tiles moving every single time, they can turn off the sound and that will be persisted throughout the game for that entire profile. And the tech stack that we used, so our infrastructure uses Postgres hosted on Supabase for robust database capabilities, and Supabase also does inbuilt hashing, so it provides a very strong authentication. And we have used Railway for seamless full stack deployment with automatic HTTPS environment management. Also, Railway automatically deploys whenever there is a new push that is done to the GitHub branch, so that was very useful. And backend uses PHP with RESTful APIs communicating with the Supabase database, and frontend is built with React using hooks and CSS with advanced animations and hardware accelerated transitions as well. And we used GitHub for version control, obviously, and whenever we pushed a new version of code, it was automatically deployed in Railway. So our database schema includes 4 main tables, actually 5 main tables, as you can see. Users, that is managed by Supabase, and public.users, this was managed by PHP for custom profiles, and game stats are used for game statistics. Background images are used for uploading the background images by certain users, and authentication flow creates entries in both auth table and the users table as well, but users table just has the entire profile of a user, and this just stores the authentication information. And we also have game states. This basically is used to resume the state of a game, state of a puzzle where it was left before a user went to another page. And user preferences, basically right now this only has the sound preference, but we can also add other types of preferences as we move on. Our authentication system uses Supabase auth with enterprise grade security. As I was saying earlier, Supabase provides us with hashing of the passwords, which provides the security. So the flow begins with React front-end credentials that would be sent to the PHP API, PHP backend, which communicates with Supabase's authentication API. So there we implement JWT tokens for session management, which gives us automatic refresh, and we also have enabled email password reset with time-limited tokens. And user profiles will be created post sign up. So that include username, email, role, registration date, sound preferences, and all of that. So session management again is handled by Supabase JWT tokens. So using JWT token gives us secure token storage and automatic refresh. So admin users have additional privileges with role-based access control. So that we will look into later on. So we have used React for frontend, as I was saying earlier. So useState was one hook that we used quite a lot. So a very simple example of how states are managed is, for example, we are on login page here, and whenever a user types in an email, set use state of set email will be called, which sets the email variable to whatever the user has typed. And similarly, we get the password as well, and we send that to the PHP backend by calling the API like this. And on the backend, we communicate the email and password with Supabase API, which gives us the response of whether the user really exists in the user table or not. Then we have multiple background system. That's how we implemented the customizable game experience. So the background upload system uses a model interface, so where we can upload the file. So uploading the file, what happens is you send the file to Supabase storage with content delivery network CDN distribution. So the images are stored with, initially the images are stored with is approved as false, which means that the image is in the CDN, but it is not approved by the admin for safe use. So once an admin previews the image and approves or deletes the image through admin interface, the image will be made public and available to all of the users. So the technical implementation basically uses 400 by 400 pixel images with CSS background position. So CSS background position calculates for each 100 by 100 pixel tile. So that creates the seamless puzzle experience. And this is how it was implemented. Next, we have admin role. So our admin dashboard provides comprehensive management through a tabbed interface for users, content approval, and game statistics. So user management includes viewing all of the accounts that are on the website, and admin can either deactivate or activate an account or change the roles of accounts, and track the registration dates and login times, etc. And content management basically focuses on viewing what all background images are uploaded by the users and preview and approve or delete them accordingly. So all of the admin functions are protected by role-based access control. So with every operation, we pass a JWT token, which gives us the role of the user, and depending on if the role is admin or not, these operations could be performed. So this is a small implementation of how content management tab, admin dashboard tab, those are aligned. And next we have leaderboard system. So our leaderboard system processes game statistics by grouping data by user and puzzle type. So we find the best time per user per puzzle type to prevent domination. So the data is stored by completion time with move count tiebreakers. So user can filter by puzzle type for specific background competitions, leaderboards. So real-time updates occur as the game complete with efficient database queries, joining user data and game statistics. So this is a small example implementation of how it is used. So here you can see that we have selected users and time taken in seconds, and we have sorted it in ascending order, and we notice how we put only 100 as a limit. That's because we are using lazy loading, and this will be called again and again as the user scrolls down, so that first we give instant results. And this is a front-end implementation of how we show the user leaderboard. This is basically a tabbed interface as well. This is basically a table interface. So you can see that it's a table with these particular columns, and this map basically iterates through all of this result. Right, so this is the application. So this is the sign up portal, and this is the sign in page. So let's sign up as a user for now. So I'm signing up as an admin. So we'll get an email for the confirmation link. gonna go there and confirm the email. Okay, so now I'm logged in, and I'm logged in as an admin. So I have access to these admin pages. This is the game statistics, so we can see all of the users that I've played so far, and the times they've completed and the number of moves, and the averages have also been calculated. And these are the background images. As you can see, a couple of them are inactive. So let's say I approve this one. Now if I go to leaderboard, I'll be able to see the users, top top end users actually, for every puzzle type. So I can filter them based on the puzzle type as well. If I go back to admin, I think we have approved this particular image. So if we come back to user management, these are the users that are currently there. You can toggle a user's state, and you can go back to team puzzle, and you can see that that particular space puzzle is now accessible. I can shuffle and start playing. So I don't know if it's audible, but you can see, you can hear the sound of tiles moving. I can click back to home, and I can choose to either save progress or discard progress. If I save progress and go back, that state will be saved, and the number of moves and time as well. And you can see that it's a resumed game. Okay, I'm gonna save progress, and I'm going to sign out now, and I'm going to sign in as another user. So you can see that there is no admin portal when the user type is just a player. And I can choose to upload new puzzle, by the way, and let's say that I give a name cow and choose file. Let's choose from the project files, public, and cow. Okay, upload the image. So now when I uploaded that image will be going to the admin's dashboard. And here as well, I can go to the leaderboard to see all of the players. And you can see that the sound is off for this user, but because I've configured it to be off, and the user preferences will be stored in the users table. Again, I can shuffle this and I can start playing. I can move multiple slides at once, and I've ensured that the game is solvable, but it's going to take quite a while because you have to make like at least 200 moves to solve the problem. Okay, now back to home, save progress, and then sign out. So if I sign in as an admin again and go to background images, you can see that cow is here now, and I approve it. And if you remember, we've changed this user to admin, and that's persisting. Now the curve puzzle is also available. So that's the demo, a quick demo of how our application works. And you can see our database here, tables and background images. So these are all of the images that are there. So this is a Postgres database, and this is our users table, and this is our game state. So this basically saves the state of a game when we hit resume. So this is the 2D array that we use to basically see the state of the table at any point of time. So when it is 0, that means that is the empty tile. And game stats is basically, this gives us an overview of leaderboard positions. So for example, I have a single user, say, re-attempting the game again and again. So the stats will be stored here, but we are going to fetch all of those rows and fetch the max of that row, max of time taken for that row, and show that in the reader board stat.